From County College of Morris, this is CCM All Access.
Hello, and welcome to Season 9 of CCM All Access, the program that brings you news and information from the County College of Morris. Students on campus, members of the community, people doing good things. I'm Nicholas Kratzel, and joining today is Mr. Kevin Conod, who is the Planetarium Astronomer here at CCM. Kevin, glad to have you.
Oh, thanks for having me here.
Sure. So, what do you do here at CCM?
I teach the Introduction to Astronomy course here at CCM. That's how I started out at the beginning of this year, teaching that course. And it's a very interesting course because it covers the whole universe in one semester, which is quite a lot, you know. Since then, though, we've also reopened the planetarium to the public, and so that's what I've been working on recently. Over the summer, we've been doing public shows again for the public, and I've had quite a lot of people coming in for those shows, families, that sort of thing, coming on in on weekends to see programs. You know.
Awesome.
Yeah.
Well, I know, it hasn't been open for a while, right?
Right, yeah. It's been closed for a while, and people seem to really miss it. It's been really very nice to hear from people who have been to the planetarium when they were younger. They remember going as kids when they were in school, and a lot of the students here at the college and staff here have been very excited about the planetarium reopening.
Definitely. Yeah. So what did you do prior to coming here?
Well, prior to coming to the college, I worked at the Newark Museum. I ran the planetarium at the Newark Museum, and I started working there right out of college. You know, I graduated with my degree in astronomy, and started working there part-time. It turned full-time, and that job lasted for 30 years.
Wow.
You know, so I was there for 30 years, and I knew that the planetarium here at the county college had been closed for a while, and so it was nice to be able to help out to get this planetarium reopened and running again.
Definitely,
you know? So that was exciting to see that happen.
I guess a big change going from there to here, or?
Yeah, because of course, you know, for years I was teaching in a museum environment, right. Which is quite different from working at a college. It's a different type of an audience, but you know, it's an interesting aspect, you know, a whole different way of looking at things, and you know, but there are similarities. We still have families coming in to see programs, and so there are some similarities.
Yeah, no, definitely.
Yeah.
So have you, with working in this field, have you always been interested in, I guess, just astronomy in general, or teaching it?
Yeah. Well, I guess when I was younger, I wasn't really into astronomy. I think I was more into geology, into rocks and dinosaurs and things like that, you know, when I was younger. But I do remember when I was in school, in elementary school, we were very lucky. I grew up in Fair Lawn, New Jersey, and we were very lucky that our school system had a planetarium in it, a small planetarium.
Really?
And so there are quite a lot of little school planetariums scattered around in this area that nobody knows about because they aren't really open to the public. They're just used for classes. And so I remember going when I was probably in 3rd or 4th grade, something like that. And so that was my first introduction to astronomy. And I really liked it, and I really loved that. And we visited the planetarium a couple of times, I think, when we were younger. And when I got to high school, the planetarium had actually moved to the high school, and they started an astronomy course. And so that was my first real introduction to astronomy, was taking a high school astronomy course. And after school, they had a little high school astronomy club, and we had a group of us that would meet in the planetarium after school, and they would let us run the planetarium and that sort of thing. And so that was really fun, and I remembered that when I finally did graduate and go to college. I remembered how much fun that was, and that became my major in college, and that's how I ended up in the planetarium field.
Yeah, I was just going to say, that must have sparked a ton of creativity, I guess, for yourself and the others, and like you said, it made you go to college for that?
Wow. Though I wasn't really 100% sure what I wanted to do, but I was interested in computers, and I was interested in physics and astronomy and that sort of thing. But eventually, that's what I latched onto. I remembered, that's something that I really enjoyed learning about, and so and I really enjoyed those courses in college, and so that's what I ended up pursuing.
Yeah, like I definitely know, like a lot. I have never met a person that has gone out and been like, oh wow, this is boring. No, I like everyone that I know is outside and looking at the stars. They think a lot of that's very interesting, and there's obviously professional people like yourself that study it. That's great,
Yeah, a lot of people do have an interest in astronomy, and so it does make it easier.
No, definitely
to teach the subject. You have a lot of people who have been interested in it since they were kids.
So do you have any like personal interests in astronomy, something that you like to specialize in, or?
I would say I don't think I really have a special specialization of any kind, though of course that's very common in any of the sciences. Some of the sciences can be very specialized. There are some astronomers who are just interested in black holes, and there are some astronomers that are just interested in planets, and so they go into the sort of planetary sciences and that sort of thing. But I kind of like a little bit of everything. I like learning about a wide variety of different topics in astronomy, especially since I do work in a planetarium and have worked in planetariums for a very long time. People ask questions about all kinds of different things, and so I try to keep up with the various aspects of the field, so I don't really have a specialization, I think. But,
definitely. Astronomy, obviously, there's, on the news, science magazines, stuff is changing constantly. So how does someone like yourself keep up with all that?
Yeah, it is difficult. There's a lot of news coming out about various discoveries, and so it is sometimes hard to keep up with that sort of thing. But you have to try to do your best to keep up with what's happening in the field, and I guess it's sometimes difficult with the way that news is distributed these days. There's a lot of clickbait, and so you'll see these headlines, and sometimes the headlines are very misleading, and that I feel makes our job as astronomy educators kind of difficult. Because people see the headlines and don't actually read the article sometimes, and so it does become difficult sometimes.
So how would you advise people to, I guess, avoid that? I guess study and figure out certain facts.
Yeah, well, certainly, when you see a headline that seems kind of crazy, read the article and see, and try to see if the person who's written the article knows what they're talking about. Or sometimes, they're credible, and sometimes you'll read the article. When you get into it, then you'll see some information that contradicts the headline.
Exactly.
And read about it, and don't read one source. Look at other sources for the similar material and see if they agree, if they all agree or not. So need to apply a little bit of critical thinking to things.
Right. Yeah. So, what have you ever what's your greatest achievement related to astronomy or anything in the science field?
Well, I suppose I would consider the greatest achievement in terms of astronomy has not been something like, I wish I could say that, well, I discovered a planet or discovered a comet or something like that, but that's kind of a rare thing. But certainly the students that I've taught and the people I've worked with has always been, I think, my greatest accomplishment. Had students have gone on to become teachers themselves, and science teachers, and some of them become involved in medical fields and nursing and that sort of thing. And but they some of them have gone into science fields, and many of the people I've worked with have gone on to run other planetariums and that sort of thing. And so I think that's been my greatest accomplishment, is the people that I've worked with and students I've worked with.
Oh, great.
Yeah.
So you're obviously a professor then. Mm-hmm. You teach here?
Yeah, I teach the Introduction to Astronomy course, and that's designed for non-science majors. And so for some students, it might be one of the few science courses they take. And so hopefully we're leaving a good impression on them in terms of the sciences. And hopefully we're teaching them a little bit of that critical thinking to carry forward with them into their future careers, and a little bit of an understanding about how science works. Because sometimes in the media, scientists are portrayed as people who are just coming up with these wild theories, but all these theories are really based on facts, and that's what I try to communicate to my students, is that, a scientific theory never really becomes facts. It's already made of facts. It's already made of experimental results and facts and that sort of thing. These theories are models about how the universe works. And you're always constantly comparing these models to the universe around us to make sure that they're working properly, and those theories are on the right track.
Yep.
Yeah.
I know for a fact with sciences, it could be so hard to get students motivated and keep them interested. How do you do that yourself?
Yeah. Well, certainly trying to relate, what we're learning about in the classroom to what's happening with current events. If there's some particular mission or some kind of mission or project or new telescope being built or something like that, I always try to bring current events into the classroom and try to relate things that they're learning about to everyday life. Because, astronomy does affect our everyday life. It's what causes the seasons and what causes the constellations to change slowly over time. And, and that's, and speaking of time, that's where all of our concepts of timekeeping comes from. It comes from observing the cycles of the universe around us. And so, so hopefully bringing some of those concepts into the classroom helps people kind of grasp what they're trying to learn.
Definitely. I know for a fact, as a student myself and talking to other people that I know that are students, it's hard to get someone interested in something when there's no real-world applications or the teacher is not explaining what it could be useful for. And I think that's great when professors and teachers explain that kind of, because it helps the, progress the class and the information along terrifically,
Yeah. So.
With that, where are you at in terms of teaching astronomy and I guess, how do I explain it? Teaching astronomy and getting it to a point where the students might want to progress it further in the career?
Well, recently I did have a conversation with one student who might be interested in that, and so, it's just really a matter of, continuing on in their studies, but also, look for other opportunities that would help them in their future career. Things like internships, whether it might be a NASA internship or an internship, maybe a summer internship at an observatory. And I've had some students do that, and where they have gotten some very nice internships at some major observatories. And so that can be very useful to expose them to some real scientific research at a major institution. That can be a big help for students.
I bet. Are there a lot of jobs in the field?
There's not a huge amount of jobs in the field. It is very competitive, but that's where those internships can really help you move forward in that way.
So would you advise your students to get involved with, I guess, a science-related job or astronomy specifically?
Well, sure. And there's a lot of different aspects to some of these careers. If you take a look at, let's say, an organization like NASA, right. Whenever you think of NASA, well, you automatically think of astronauts. And well, sure, yeah, becoming an astronaut is really cool and a really, a great goal for someone to have. But there's only a small number of astronauts, people that get selected. It's highly competitive, and only the sort of elite get picked to be an actual astronaut. But there are a lot of other jobs that are also very, very important that are related to science and astronomy. NASA needs engineers to build the spacecraft that design and build the spacecraft that those astronauts are getting into and launching off to the moon or wherever. And so there's engineering positions, and there are a lot of other careers that are related. There are people who are making and designing the astronaut suits that they're, the spacesuits that they're wearing, and designing the software that they might use, and so they're also hiring software engineers, and so there are a lot of different people involved in the background in NASA that you never hear about, and those careers are very are vital to the agency as well, and that's true of any astronomical institution, whether it's an observatory or university. A large amount of most of the research is not really done by an organization like NASA. Most of the research is taking place on a smaller level at universities.
Interesting.
And you have these big teams of astronomers that are working with each other. And of course, these days, a lot of stuff is done remotely. And so some of these teams are spread out all over the country or even all over the world, working together on some of these projects, trying to answer questions about the universe. And there are, the astronomers themselves are doing research, but they also have people that are helping them, again, with engineering. You need an electrical engineer to design the mechanical engineers to design the instruments that you're using, and so there are a lot of related careers there too that you can be involved, even if you're not a PhD astronomer. There are still careers in astronomy that people might be interested in.
Yeah. Do you think with like you said, people are connecting virtually and stuff with that, do you think the last 2 years of what has gone on in the world, do you think it's slowed back the advance of what people are doing in terms of astronomy with COVID and stuff?
Well, I think it has slowed things down, sure. And I think all scientific fields have been affected by COVID, even though some people can do or have done their work remotely. It still has kind of slowed people down a little bit, And, certainly it's a bit more difficult for international conferences and things like that to happen, and where a lot of work and collaboration and networking gets done that has been delayed or reduced over the past couple of years. And well, things are starting to come back now, and things are ramping back up, and so things seem to be moving along pretty well at this point.
Do people need to be together for that kind of work to be done, or can it be done?
Some of it,
significant work. Yeah.
Some of it can be done fairly remotely, and that's becoming more common over time. Unrelated to COVID, is that you can save a lot of time and effort, and you can reduce your carbon footprint by not having to travel off to some other part of the country to go visit a major observatory, any part of the world to visit an observatory. Some of our major observatories in the world are in Chile and South America. You've got Hawaii, another major area, the Canary Islands as well.
Oh, wow.
And so, it's expensive and it costs a lot of jet fuel to fly an astronomer off to one of these observatories to go up on a mountaintop and go use a telescope. Whereas, these days a lot of that is done remotely.
Right.
And some of it is just simply scheduled in advance.
Definitely.
The team of astronomers will sit down and make a plan for when their observations need to take place, what objects need to be observed and for how long and with what instruments, and that's all planned out in advance. And when the skies are clear, well, then those plans will be executed, and eventually you get that data back sent to you. And so that part of it can be done remotely. But you always have to have some staff on site in order to operate that observatory and change the instruments and fix problems when they occur and that sort of thing. But the astronomers themselves can do some of that work remotely.
Definitely. Yeah. Have you ever been to one of those major observatories?
Yeah, I've been lucky enough to visit Hawaii. Mauna Kea is one of the best observing sites in the world. It's up high. You're up, I think, about 14,000 feet at the summit, something like that. So you're up high, so you're above a lot of the local weather, not all of it, but you're above a lot of the clouds. And so you're up there in a very thin atmosphere, and so you don't have much atmosphere to look through, and so you get a really nice view of the universe from someplace like that. You're near the equator, so you can see a good chunk of the sky, and you've got some beautiful conditions there where you can do observing. And I was lucky enough to go on a tour of the Keck observatories, which until recently were the biggest telescopes in the world, 10 meters in diameter. So you're talking something that's a little bit more than 10 yards across, so that's huge. And there are two of them side by side, and we got to view the telescope, get a little tour, watch them go through their pre-check for the evening observations, watch the telescope move around, and so that was really quite amazing. And on another opportunity, had another opportunity to view the interior of the Subaru telescope, which is run by the Japanese. It's their biggest telescope, and which is also really quite an amazing instrument. And so yeah, I've been lucky to view, to take a look at those observatories and watch the sunset. Watching the sunset on Mauna Kea is really quite amazing.
Wow.
Being at 14,000 feet and watching the sunset over the observatories, watch the stars start to come out. That's pretty amazing.
That's crazy,
experience.
actually. Yeah,
it's an
very
amazing
interesting.
experience. Yeah.
So you kind of touched on this, but like the observatories, they seem to be in specific places like islands. Is that, like you said, is that because of the area that it's in, like it's easier to see the stars and what's going on, or?
Yeah, well, there's no particular preference for islands, but it just so happens that you've got a couple of volcanic islands like Hawaii and the Canary Islands, where you're kind of in an isolated area. You're surrounded by water, so you don't have to worry about city lights, interfering with your viewing, that sort of thing. But it just also seems to help with just the way the air flows up over the mountains. It's very kind of a smooth flow of air, and that creates a very steady, gives you a very steady environment to observe things. And the similar conditions exist in Chile, in the Atacama Mountains, the Atacama Desert, I should say. It's a very high altitude desert, and it has similar conditions where you have kind of this very smooth flow of very dry, clear air. And that's also a fantastic spot for observatories. There's a whole cluster of them. The Europeans have a major observatory there, and we have a couple of different American observatories, as well as others too that are, and a lot of these are international projects, and a lot of different organizations, different universities that are involved in them. And but those are really good sites. They're above, they're high in the atmosphere, so you're above a lot of the atmospheres, you're above smog and some of the local weather, and hopefully since you're on a mountain, you're away from some of the light pollution and that sort of thing, So that's really why we do that. We put observatories up high so that we're looking through less atmosphere. It's not that we're closer, it's that we're looking through less of the atmosphere. Because when you're down at sea level, you're looking up at the stars, and I'm sure many people have noticed that the stars will twinkle. you know, and that's the turbulence in the atmosphere, in the lower atmosphere.
Oh, really?
It's turbulence, and that's creating the stars, or the flickering the light of the stars. And if you're trying to look at something at very high resolution or high magnification, well, that's going to really blur your view. If you're looking at, let's say, a planet here at sea level, and sometimes you can barely see any detail because it's fluctuating so much. It's like looking at something from the bottom of a swimming pool. You know, that's what the turbulence is doing. It's kind of smearing out your view, and so by getting up high above the atmosphere, it was avoiding some of that, and so you're getting some nice, steady, clear air to look through.
I mean, prior to you telling me this, I had no idea that there was that much that went into play with that.
Yeah. Oh, yeah.
That's amazing.
Yeah, it's a major thing for observing, and in some cases we've been able to get around some of that through a special technique, which is usually referred to as adaptive optics. And basically what it involves with is making an artificial star. And so what you do is you take a laser and you shoot it up into the sky, and that becomes your artificial star. And so you watch what that artificial star is doing as it fluctuates.
Wow.
And you can take your mirror and you can deform your mirror to cancel out some of that. And so it makes a much higher resolution image possible. And so some of our ground-based telescopes now are able to operate at a level of resolution that almost equals what a space telescope can do. You know?
Really?
Yeah, almost. Not quite, but it does a pretty good job. And so adaptive optics has been a big revolution over the past several years. You know,
that's amazing,
high
actually.
resolution images. Yeah, it's pretty amazing. You know.
So there's a lot of, I guess, not manipulation, but manipulation you can do.
Yeah.
You know, with I guess the environment and seeing how things work in astronomy.
Yeah. Yeah.
Wow.
Yeah, you can do all kinds
and
of
lasers
things.
are just one of them, like you said.
Yeah. There's other techniques, other tricks that we use to increase or sort of clarify the images than the data that we're collecting. One of them with radio telescopes is to take a bunch of radio telescopes, instead of try to build one big radio telescope, which is difficult. You build a whole bunch of smaller ones and then spread them out over a large area. And you can take all those telescopes and kind of gather them together so that they kind of function as one big telescope. And so you can make a radio telescope as big as the United States. You take the telescopes and build them in different parts of the country, and then kind of gang them all together, and they kind of operate like a big giant telescope.
They're all connected.
They're all connected together,
Wow.
And so there are different tricks that astronomers use to get around some of the limitations of our equipment and limitations of our environment to try to overcome some of those limitations.
Right. I guess, like you said before, especially like where they are, if they're in a zone where, like if they're in the city, it's going to be hard to see with all the lights and stuff. So
and that's an increasing problem for astronomers as well as others as well. It's not just astronomy. Light pollution has been a big challenge over the last 20, 30, 40 years. The light pollution has just completely soared. And LED lighting, unfortunately, even though it's cheap and it's more efficient than older lighting, people have been kind of getting carried away with that, and they're putting up lights everywhere. Yeah. And so they're trying to turning night into day, and that's of course terrible for astronomy, but it's not good for us either, because human beings we are not designed to have for 24-hour sunlight. It disrupts our sleep cycles, and turns out it's really kind of not very good for us. It can increase rates of cancer because if you expose the human body to light at night, it shuts down our production of melatonin, which is a strong cancer fighter. So, not only do we have, cancer that's already a problem, we're reducing our natural, defenses against it, and it also is harmful for wildlife. It's not good for wildlife. They're not set up for 24-hour light either,
Yeah, I mean, you hear that all the time with the turtles and
the big
like
news.
That.
I don't know if anyone saw it, but this past summer there was a big article in the New York Times about fireflies. people remember when they were kids, there were a lot more fireflies around. And well, that's the thing, is that those
I never see them anymore.
There's these little lights, those little lights that they give off. Those are mating calls. You know, so it's kind of like a nature's version of Tinder for fireflies.
Okay.
You know, and if you have so much light pollution that the fireflies can't see each other and can't see their lights, well, there goes your Tinder. The mating level goes down, and so there are less firefly babies, and so the next generation there are less fireflies. And of course, there's also pesticides and other problems that are affecting them too. But you're reduced to that's the population is being reduced. You know, and so there's less for other creatures to eat. You know, if you reduce the insect population, it can affect the life cycle of birds. You know, because that's what they eat. They eat bugs. You know, so there's these unintended consequences of all this light that is. So it's beyond astronomy. There are other effects too that people are starting to become aware of. You know?
Wow. So, I mean, I'm sure you understand this too. I mean, most part, people really aren't talking about light pollution as much as the other types, and it's affecting animals. I didn't realize that it was affecting that many. I knew, like, obviously everyone's always heard of, you know, the turtle example, and but the fireflies. Wow, that's interesting. Wow.
So. Yeah, some of these unintended consequences can be difficult.
Right.
It's not as serious as a problem as
outside
other environmental
problems
that we have, but still, it's another aspect of it.
Yeah. So, what kind of qualifications would someone need to get involved with not only that, but seeing these telescopes and whatnot around the world? I guess getting involved with science.
Well, yeah, I mean, and there's other ways to get involved with, you know, various scientific fields beyond just, you know, careers. You know, a lot of people will take up some of these sciences as a hobby. You know, there are a lot of, you know, astronomy clubs around in New Jersey. We're fortunate to have quite a few astronomy clubs around, and you know, there's you know, even geology clubs and clubs for people who are interested in fossils and, you know, things like that. So there's a lot of different ways of getting into the sciences besides just taking a degree in it, you know. But so yeah, of course, people can go into that as a career, but even if people are just interested in a topic, they can still participate. And actually, that's a brand new field that's called citizen science.
Really?
There are projects that people have started that will allow the general public to help gather data for various projects, you know. And you know, there was one project during COVID that they had started where some researchers wanted to study proteins related to COVID. And in order to do some of those studies, you need a lot of computing power. And so, well, you have a lot of the people, everyone has some kind of computer at home these days, usually a laptop.
Plus at the time, everyone was home.
Some kind of device, and everyone was at home. And, you know, sure, they're working at home and they're using their computer, but then at night when you go to sleep, well, the computer is there. Sometimes it's on, but it's not doing anything, you know? And so there was a project similar to this a number of years ago that was involved with the SETI program, Search for Extraterrestrial Intelligence, which is SETI, S-E-T-I. And they had a similar issue where they had all these radio signals, and they're looking for artificial signals that could be coming from some kind of alien life. And you need a lot of computing power to do that. So what they did was they used people's idle computer time. You ran a little piece of software and would go, and it would, at night when your computer, instead of going to sleep, would sit there in the background and would process these signals, looking for artificial signals, you know. And so that was started many years ago. And there's other projects like that with, you know, this protein, I think it was a protein folding project related to COVID that could do something similar where they're searching for a certain aspect of the proteins, and you know, so they were making use of this idle computer time, and so that was one way to be involved with science in one of these you know, citizen science projects. There's another one that searches for comets, and people can go on to some websites and see a little tutorial, a little training session to look for comets being picked up by instruments that are actually aimed at the sun, and you can sometimes spot comets going behind the sun in their orbits, and so you can search for and discover comets, perhaps. And a couple of people have done that. Have actually discovered comets that way, and there's other projects related to asteroids, and another one where you help astronomers categorize galaxies, because galaxies come in different types, and you can put them in different categories by looking at their shapes. And so you can look at the images that are coming from telescopes, and you can try to help put them in categories.
Right.
And so there's all of these different types of science projects. Some are biology, some are astronomy, some are physics that you can be involved with. Even if you're not a professional, you can be involved in these citizen science projects.
Right. Yeah. That's amazing, like the citizen science, kind of what we were talking about before with, you said citizen science, using people's hobbies to kind of advance real world issues and help them. That's amazing.
Sure.
So I just want to move back to something really quick.
Yeah.
Big question about the extraterrestrial life.
Yeah.
What do you think about it?
Oh, well, I think most astronomers think that, sure, there's certainly a possibility that there is life out there, that we're not alone in the universe. It's just a big question as to, where are they? Why haven't we picked up any radio signals yet from these other peoples out there? Hopefully there is intelligent life out there. I think most astronomers don't think that we've been visited by intelligent beings quite yet, even though there are lots of reports about UFOs. We've never really been able to show that those are really extraterrestrial, but I think most astronomers believe that there is, but believing that it's true, of course, is not science. We have to actually prove it.
Right.
We actually have to show that there is some kind of life out there, and perhaps the new space telescope, the James Webb Space Telescope, which has just come online in the past few months, been putting out new images. Hopefully it's big enough that it can look at the atmospheres of some of these other planets that are close by to us, and we could try to figure out what those atmospheres are made of, what other signs of life that we can detect from looking at their atmospheres. And so we might be close. We could be much closer at this point to proving that life exists elsewhere in the universe by doing these studies of these extrasolar planets out there in our neighborhood.
It's interesting because you see, like now, there used to be such a focus on like how have we not seen how have we not seen this life, and you've seen between media and movies and culture. It's now how can we advance science and maybe find some of these beings or life forms, and it would revolutionize everything that we know.
Yeah, pretty astounding thing to discover, that we're not alone in the universe. And it's a very, very profound and very long-standing question. I mean, people have been asking that question for almost 400 years, whether or not there's other planets with life on them, Fortunately, they're probably one of the first people to kind of popularize that idea was Giordano Bruno. And, along with that idea, he talked about how he believed that there was life on other planets, but that wasn't really compatible with the church, and a lot of other things that he taught were not compatible with the church, and he ended up getting burned at the stake, unfortunately. So it was a rather unfortunate end for Mr. Bruno. So people were very opposed to that idea, but obviously things have changed over the past 400 years. And I would say that most people would think that we are not alone in the universe, but for astronomers, it's really a matter of actually proving it. We have to come up with some real solid evidence that it actually does exist.
Right.
And that would be really exciting if we're able to find that.
Definitely.
And that's certainly something that NASA is involved with right now. A little bit closer to home, we do have 2 robotic rovers on the surface of Mars.
Right.
And the latest one is called Perseverance, and that is one of the things it's doing is looking for not necessarily current signs of life, but seeing if there was life in the past, because we know that Mars was much wetter in the past. And so
had a lot of water on it.
It had a lot of water,
Yeah.
a lot of water, and that doesn't really exist anymore, though some of it is still there in the form of ice, but perhaps there was enough water there for long enough that life may have developed there. So that would be interesting to know as well, if life existed in the past, would show that it's possible, at least, that life could arise on another planet besides just the Earth. So that would be an important clue too, and so that's something that the Perseverance rover is working on right now.
So is the rover just kind of, I guess, analyzing what's going on, or is it actually taking like samples and whatnot?
Yeah, that's the sort of more innovative part of this particular mission, is they actually are taking samples. Of course, they're doing some analysis on site, but they have little, kind of these little test tubes that they're filling up with material. And it's leaving them behind. It's collecting the material, but then it's dropping them on the surface. And they're kind of like little breadcrumbs. As it drives along the surface, it's leaving behind these breadcrumbs of information. And the plan is that in the near future, the Europeans will build a follow-up mission that will land and pick those up and grab all those samples and collect them together, put them in a capsule, and then shoot them back to Earth. And then
how long will that be, though?
It'll take a while. I mean, it's going to be, you only can launch every 2 years when Mars is closest to us, is when you really want to, that's the ideal situation to launch. So that only comes once every 2 years. And so if the spacecraft is not ready for 2024, they're going to have to wait till 2026 to launch that, and so it
could be a while.
So it could be a while before that actually happens, and so yeah, it could be a wait. But once they do get it, it'd be really exciting to actually have real samples of Mars here on Earth to be looked at in the laboratory up close.
Right. Well, I know for like a number of years, people thought it was so cold that, like the permafrost was almost impossible to kind of take samples from. I guess now I didn't even know that they had sent that.
Yeah.
Wow. Okay.
That's been there. The Perseverance rover has been there for about a year and a half now or so.
Okay.
So it's relatively recent, relatively new mission.
Right.
Yeah.
Is it a struggle getting it to the actual planet, or?
Well, yeah, anything like that it takes quite a bit of planning and engineering and design and that sort of thing, And for some reason, we seem to have a lot of trouble with Mars. We've lost more missions on Mars than any other place.
Really?
I think. Just some have been kind of mishaps, equipment failures and things like that. But space travel is difficult. There are a lot of things can go wrong, but fortunately, we've been lucky. The past several missions have been pretty successful. We've landed, I guess, three or four rovers on Mars in a row, and have not had any difficulties, so that's been good.
Well, I know there was like a brief period in I think it was late 2010s where we weren't getting like funding, right? It was hard to get funding for certain missions, right?
Sure, yeah. There's been occasionally have been gaps here and there in terms of different types of missions, but lately, fortunately, the budget has been pretty good. They've been able to fund a number of really interesting missions. We have one that's coming up sometime in the next few years that's really interesting. Speaking of life in the universe, it's a little mission called Firefly, and basically they're going to send a drone to Titan, the biggest moon of Saturn, which actually has an atmosphere. It's big enough that it has an atmosphere, and it has a really interesting surface, and there's liquid ethane on the surface, and so we'd like to send a drone that could fly out across the surface and scan large parts of the surface, so that's something that would be really exciting to go and look and see if there's a possibility of life happening on some place like that,
Right.
So
or if there was.
Or if there was in the past, yeah.
Wow, okay. So they'll send the drone to Titan.
Yep.
They'll take the samples, and it'll
Yeah.
stay there, or it'll
Yeah,
come back?
it'll stay there. Yeah, it
Okay.
won't be able to come back, but it would be able to take pictures and that sort of thing, and scan across the surface.
Wow.
Yeah.
Okay. How long do you think that would take to get there?
It takes a while, because you're talking Saturn is almost 1 billion miles from the Earth,
Kinda
so it's
far.
several years to get out
Yeah.
there. When we sent a probe to Pluto a number of years ago, I think that was 2014 or 2015 that it finally reached Pluto. It took 12 years to get out there, because
It took 12 years to get out there?
It's 4 billion miles from the sun, so
It's a little bit
and
far.
so that's far, and that's a very nerve-wracking type of mission for the people who are working on it. Because some people spent their entire career working on that one mission, because it took 12 years to launch. So
Right.
it took a number of years to build, several years to build, raise the money for it, and then build it, and then launch it, and then you got to wait 12 years for it to get to where it's got to go. And then what happens if it fails?
Well, I was
and
just going to say
you've wasted
that.
all that time, Boy, that's rough. I would not want to be one of them.
I was just going to say that. Like, imagine spending your whole career building this robot, getting the qualifications.
Yep.
For it to go, for it to launch. Launching, it's like 8 years in, and it fails.
Yeah.
That's, I guess, one of the difficulties of.
It could happen,
Wow.
And so it's something that people who go into that type of work, they have to be aware of that, and they have to know that it could happen,
Right.
So,
So, are we? I don't know if you know the answer to this question, but in terms of sending, things into space, are we only searching for life, or are we searching for sustainability, I guess, for, future options?
Well, I mean, most of the exploration really is, science-based. I mean, you have to have some real good science goals and sort of general goals. So we're not just looking for life. That's not the only sort of criteria. There are other scientific goals, and in astronomy, it's very nice because about every 10 years, the astronomers will get together and kind of make a 10-year plan. Kind of decide, well, what's important? What are the important questions that we want to answer over the next 10 years? It's called the decadal survey, and it's a very long process that the astronomers go through, but it's really valuable, because then you can try to focus your funding on certain projects and get certain questions answered, in that period. And so it's organized in a nice way, where you can kind of set some goals for your scientific exploration and the funding that goes with it. And so it's a nice way to organize things, and you can try to answer as many questions as possible, with the funding that you have.
Right. Does that conference, I guess, happen on like a national level, or is that like an international type of thing?
That's really more an international type of thing, where a lot of people are involved from different teams from all over the world, and people make proposals, and you get a huge number. Start out with a huge number of proposals, and you have to whittle it down, which can be very difficult to only a few. And so it can be a difficult process, especially if your project doesn't make the cut.
No, definitely,
But again, that's a possibility that might happen.
You got to take a risk for that, I guess, right?
Yeah.
And I guess those ideas will eventually make it back to certain governments or funding agencies and whatnot, right?
Yep.
Okay.
Yeah,
and then they'll find a way to proceed with how they're going to go out with the research and experimentation. Wow.
Yeah.
Okay. Interesting. Have you ever been a part of anything like that, or?
No, unfortunately, no. I haven't been a part of any of the big projects, but it's interesting to watch them develop and grow over time.
Right. Yeah. Interesting. So, like as you know, obviously, here we have Longo Planetarium, which recently reopened, and can you tell us about how people can get involved here at CCM?
Yeah, well, certainly, as mentioned, the planetarium has reopened to the public, and so people who are interested can come see a show. and those happen basically every other week. Once every 2 weeks that we have a weekend public show. So we're open on Friday nights and Saturday afternoons.
Okay.
And you can check the website to see what the exact dates are, but it's roughly every 2 weeks we're open to the public. And so those are happening, so you can come in and learn a little bit about the universe. And after the show is over, whatever the show happens to be about, well, always includes a little tour of the sky. We always like to show people what stars and constellations and planets are visible, so that when they go home, hopefully they can go out in their backyard on the next clear night and see some of those things and find them on their own.
Be able to talk about it, right?
And be able to talk about it, And so, that's something that we try to do for all of our public programs. And in addition to that, we are starting to get school groups and other types of groups that'll start coming into the planetarium to come in for field trips for the planetarium to see programs as well. And so that will be coming back this fall and running into the spring.
Wow.
So that's.
You said field trips?
Yeah,
Really?
School field trips coming in to the planetarium. So then we've got some 5th and 6th grade classes coming sometime in the next few weeks. So that's also another aspect of the planetarium that will be running sort of in the background as well.
Right.
So, yeah.
So will students be able to, I guess the students here at CCM, they'll be able to go into the planetarium for shows?
Sure, yeah.
Right.
And certainly you can buy tickets for any of the shows. But also we are setting aside a time slot just for staff and students. So on a regular basis, we'll be having a free planetarium show for staff and students, and that will be on the 3rd Tuesday of the month.
Third Tuesday
of the month. In the college hour time slot at 12:30. We'll be running a free show. And so we did our first one recently, and we had a pretty good attendance, and hopefully as time goes on, people will come and check out a show.
Awesome. I'm sure people are really interested because I know you and I had talked about this prior, but it's like that one door that exists on campus. No one really knows what's inside of it, and now it's open. So that's great. I'm sure you're excited about that, right?
Oh yeah. It's very exciting to see people coming back in to this planetarium, and it's as I said, people have been really excited about it, and it's nice that the community is so interested in it, and so we're going to get more and more. Can add more and more programs as time
Getting
goes
people
on.
involved, yeah. So, as we talked about, students are able to visit it. Do you have a certain thing that you like to visit? Like, are you part of an astronomy club or?
Well, certainly, yeah. I've been involved with astronomy clubs myself for many years, and as I said, I started out. One of my first exposures to astronomy was in high school, and I was a member of the high school astronomy club.
Right.
And so I've been involved for a very long time with astronomy clubs, and I help run an astronomy club that's called the North Jersey Astronomical Group that meets at Montclair State. But there's also some very nice astronomy clubs here in Morris County, in this part of New Jersey. We have the Morris Museum Astronomy Club. Meets regularly there at the Morris Museum, but there's also the Sheep Hill Astronomy Club as well in Boonton. They have a little observatory up on top of the hill there on Sheep Hill in Boonton, and they recently finished repainting their dome, I hear, and they're going to be reopening soon to the general public as well. And so people can do some stargazing as well with a pretty nice sized telescope in their observatory.
That's great. Yeah. So the attendance for these are pretty good, I guess, then, right?
Yeah. Certainly for our planetarium shows, attendance has been really quite good. And the astronomy clubs, have a lot of their programs have shut down for COVID, but now they're starting to come back, and
I was just
people are coming back and very interested in looking through our telescopes and that sort of thing. And so there's been a nice resurgence of interest.
Right. So I was just going to say, when COVID happened, I guess all that that astronomy club related activity, I guess it stopped? Or,
Yeah. A lot of it stopped. A lot of it, like most things, went online.
Okay.
Meetings were held online, and to a certain extent, some clubs, certainly my club, got a little involved with doing some virtual stargazing. We'd hook up our telescopes to Zoom and display objects for people, live images of objects. And that was kind of fun. Not quite as nice as real observing in person, but it was a nice substitute for a while.
Right.
But it's nice to get people back at the eyepiece and be able to see it with their own eyes, rather than looking at an image.
Yeah. I mean, I'm sure they're glad to be back, being in person and stuff. It's hard to work virtually and see.
Sometimes,
not even just work, but see what's going on. It's through a computer lens instead of seeing it with your own eyes. It's very different. No one would have ever realized that. Right?
Yeah.
So this is a question I have unrelated to astronomy. I always ask this question. How do you feel about students going to a community college instead of going to a four-year university?
Oh, well, I think it's a great way to start out. It's a good way to kind of ease into a college education. It's a good introduction, and of course the cost is less. You get to perhaps it's a time to try out some different things, especially if you're not really sure what you really want to do. As I mentioned in my own career, I wasn't, sure, I was interested in astronomy, but I wasn't really sure what I wanted to do as a career, and so I tried out some different things when I started out in college. I took some physics courses, I took an astronomy course, I took a geology course, I even took an archaeology course. I took a couple of them, in fact, because it was just wasn't something that I was interested in, and so it is an opportunity to try out some different things before you settle on a career path, and so it's a good way to get started.
No, definitely. Yeah. Did you go to community college or no?
No, actually I didn't, but I know a lot of people who have done that. I have a lot of people in my own family that have done that, and it's a good way to get started.
Okay, awesome. So in terms of, back to astronomy really quick, sorry for the side note, but do you have a favorite astronomer?
Oh boy,
there's tons of them.
Yeah, favorite astronomer, that's tough because there are just so many. But certainly in my astronomy classes, I try to make that impression on my students that, we're always kind of building on the past, and there's a famous quote that we always use from Isaac Newton, and he at one point wrote that if I have seen further than others, it's because I stand on the shoulder of giants. And so that's a very common expression that we use in astronomy. We stand on the shoulders of giants. And so you have these people in the past that have done all this kind of amazing work, that leads up to where we are today. We've been building on that for centuries, and so you have people in ancient times doing amazing things. You have people like Eratosthenes, who came out and came up with a way to measure the size of the Earth using almost nothing. He just used shadows. He was looking at shadows, and he knew that the people who were down in a city to the south of where he was in Alexandria at the summer solstice, there were no shadows. If you looked at a pillar, there was no shadow. But when he looked at the pillars around his town in Alexandria, he could see a shadow. And so he knew that the Earth was curved, and it just was a matter through simple geometry figuring out how much it was curved. And he came out with an estimate of the size of the Earth that was probably within a couple of % of the modern value, using almost nothing in terms of instrumentation, And so it kind of did some amazing, these ancient astronomers did some really amazing things. And so, you kind of go through history and you see all these amazing people that have done great things, Isaac Newton and Galileo, one of the first people to turn a telescope on the sky, make all these great discoveries, right up until the current day. And you look at people like, I like to mention Carl Sagan to my students, who in his time was one of the most well-known astronomers of his day. And he wasn't born here in New Jersey, but he grew up here. He graduated from, I think it was Rahway High School, if I remember correctly, and he became really quite a famous astronomer. And so, we're kind of building on this information that these previous astronomers, these things that they've discovered, and we're building on that. And the current generation of astronomers is passing the torch on to the future generations to go on and carry the work on for hopefully centuries to come.
Right. That's great. I mean, I'm always left mind blown when I think about, how long ago this happened and the little materials that these people had.
Yeah.
You know.
I mean, when you look to the most earliest times, it's often said that astronomy was the earliest science, because we find sketches in caves, on cave walls. We see sketches that kind of look like constellations. Right. And those drawings are, 12, maybe 20,000 years old, Right. So people have been looking at the sky for a really long time.
Right. That's great.
Yeah.
Well, Kevin, I'm glad I got to have you on today.
Yep.
This is a great experience.
Yep. Well, glad to be here. Thanks for having me here.
This has been another edition of CCM All Access. Thank you for tuning in, and we'll see you next time.